EPC means evolved packet core. This is the only difference in between 3G and 4G. And the evolved Utron, which is also called as E-Utron, is the network which handles the EPC, right? Radio communication with the mobile unit. And this is a table which shows the comparison in between 2G, 3G, and 4G. So radio access methodology used in GSM is FDMA and TDMA combination. UMTS is wideband CDMA, and 4G OFDMA, orthogonal frequency division multiple access, and subcarrier FDMA. And what of the speed? Downlink and uplink speed, both in 2G it is 10 to 100 kbps. Here it is around 384 kbps, 100 to 150 mbps. You can see the bandwidth. It is only 200 kilohertz, but this is 5 megahertz, and it is up to 20 megahertz. Modulation types used: Gaussian minimum shift keying. It is GMSK, means Gaussian minimum shift keying, quadrature phase shift keying, 16 quadrature amplitude modulation, and 64 quadrature amplitude modulation. The core network, this is completely switched, circuit switched network. This is somewhat in between, like some parts are circuit switched and some parts are packet switched, but this one is fully IP based. So communication support, it supported complete mobile communication network. Here email means MMS is supported here, and this one supports high speed data communication and internet access and rely on GSM. And what are the high level requirements for a 4G technologies? High spectral efficiency, reduced cost per bit, right? Efficiency was increased, power efficiency, and then flexible usage of frequency bands. So LTE A system architecture. So this consists of EUTMS, sorry, UMTS, EUMTS. UMTS means the 3G, what we have discussed earlier. So this is evolved UMTS, means advanced version of 3G, and the advanced version of TRAN, means terrestrial radio access network, which is called as evolved Utron. So this network architecture, it is like this. Here we have a mobile user. This is a kind of base station. This is a kind of network subsystem, and this is the server packet data network. So user equipment means the mobile station. So what it consists of? It consists of mobile equipment plus SIM card, universal subscriber identity module. So EUTRON means this is base station basically. In 1G we call it as base station, BSC. In 2G and 3G we call it as RAN, radio access network. Yes, someone has raised the hands. Akhilesh, you have any doubt? Akhilesh. And then The radio access network, this is basically a base station, EUTRON. Okay, so it handles radio communication between mobile and EPC, like a base station which handles the communications between the mobile user and the network subsystem. I can show you that figure once again. This is that figure. Okay, so this is the base subsystem. There we call it as EUTRON in 4G, right? So this is basically a 2G network, a 2G network architecture. Here we call this as NSS, but in 4G we call it as EPC, right? So here we call it as mobile station, but in 4G we call it as user equipment. So this is PSTN and ISDN. There we call it as packet data network. This is how the network subsystem or the architecture changed. Architecture from 2G, how it changed to 3G. This is 3G, right? And from 3G, how it has changed to 4G, right? This is the in-depth architecture showing the various mobile users and various base stations or eNode B or EUTRON. And this is the network elements which are present in the network subsystem. How we had HLR, VLR, EIR, authentication center. In case of 2G, here we are having these different network elements which are present in the network subsystem. Okay, so this is basically a LTEA system architecture. Okay, so what they might ask in this particular chapter is uh, the GSM network. Okay, GSM network architecture they might ask. See, what is PDN gateway? Okay, so this is PDN gateway. So it communicates with the outside world, and this is the serving gateway. SGW ಅಂತಂದ್ರೆ serving gateway, PDN-GW ಅಂದ್ರೆ packet data network gateway. Okay, so this communicates with outside world. The serving gateway acts as a router and forwards data between the base station and the PDN gateway. ಅಂದ್ರೆ ಇದು ಒಂದ್ ರೀತಿ MSC ತರ ಆಕ್ಟ್ ಮಾಡ್ತದೆ. ಈ MSC ಇಂದ ನಾವು ಹೊರಗಡೆ ಹೋಗ್ಬೇಕಂತಂದ್ರೆ 2G ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಿದ್ವಿ, ಇಲ್ಲಿ ಗೇಟ್ವೇ MSC ಅಂತ ಇತ್ತು. ಇಲ್ಲಿ MSC ಇತ್ತು, ಇಲ್ಲಿ ಗೇಟ್ವೇ MSC ಇತ್ತು. ಈ ಕಡೆ ನಮ್ದು ರೇಡಿಯೋ ನೆಟ್ವರ್ಕ್ ಇತ್ತು, ಈ ಕಡೆ ನಮ್ದು ಬೇಸ್ ಸ್ಟೇಷನ್ ಇತ್ತು, ಈ ಕಡೆ ಮೊಬೈಲ್ ಸ್ಟೇಷನ್ ಇತ್ತು. ಅಲ್ಲಿಂದ ಡೇಟಾ ನಾವು ಹೊರಗಡೆ ಕಳಿಸ್ಬೇಕಂದ್ರೆ ಇದ್ರ ಮುಖಾಂತರ ಹೊರಗಡೆ ಕಳಿಸ್ತಿದ್ವಿ. ಇಲ್ಲಿ ಕೂಡ ಸೇಮ್ ಥಿಂಗ್. ಸೊ MME ಅಂತಂದ್ರೆ ಮೊಬಿಲಿಟಿ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಎಂಟಿಟಿ. ಅಂದ್ರೆ ಆ ಮೊಬೈಲ್ ಯೂಸರು ಒಂದು ಲೊಕೇಶನ್ ಇಂದ ಇನ್ನೊಂದು ಲೊಕೇಶನ್ಗೆ ಹೋದ್ರೆ ಅವನ್ ಲೊಕೇಶನ್ ಅಪ್ಡೇಟ್ ಆಗ್ಬೇಕು, ಅವನ್ ಪ್ರೊಫೈಲು ಹೊಸ ಸೆಲ್ ಅಲ್ಲಿ ಅವನ್ ಪ್ರೊಫೈಲ್ ಎಲ್ಲ ಸ್ಟೋರ್ ಆಗ್ಬೇಕು, ಅವನ್ ಡೀಟೇಲ್ಸ್ ಎಲ್ಲ ಸ್ಟೋರ್ ಆಗ್ಬೇಕು. ಅದರದೆಲ್ಲ ವರ್ಕ್ ಇಟ್ ಈಸ್ ಕ್ಯಾರಿಡ್ ಬೈ ದಿಸ್ MME. ಸೊ HSS ಮೀನ್ಸ್ ಹೋಮ್ ಸಬ್ಸ್ಕ್ರೈಬರ್ ಸರ್ವರ್. ಓಕೆ, ಸೊ ಇಟ್ ಮೀನ್ಸ್ ದ ಡೇಟಾ ಬೇಸ್ ಆಫ್ ದಟ್ ಯೂಸರ್. ಅಂದ್ರೆ ಪ್ರೊಫೈಲ್ ಅಂತ ಏನ್ ಹೇಳಿದ್ದಲ್ಲ, ಪ್ರೊಫೈಲ್ ಅಂದ್ರೆ ಏನು, ಆ ಒಂದು ಡೀಟೇಲ್ಸ್, ದ ಡೀಟೇಲ್ಸ್ ಆಫ್ ಒನ್ ಮೊಬೈಲ್ ಯೂಸರ್, ಓಕೆ, ವಿಲ್ ಬಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ದಿಸ್ ಇನ್ ಹಿಸ್ ಏರಿಯಾಸ್ HSS. PCRF, ಈ PCRF ಅಂತಂದ್ರೆ ಏನಂದ್ರೆ, ಇಟ್ ಈಸ್ ಅ ಸಾಫ್ಟ್ವೇರ್ ನೋಡ್ ಡೆಸಿಗ್ನೇಟೆಡ್ ಇನ್ ರಿಯಲ್ ಟೈಮ್ ಟು ಡಿಟರ್ಮೈನ್ ಪಾಲಿಸಿ ರೂಲ್ಸ್, ಡಿಸಿಷನ್ ಮೇಕಿಂಗ್, ಮಲ್ಟಿಮೀಡಿಯಾ ನೆಟ್ವರ್ಕ್, plays a key role in VOLTE as a mediator of network resources, offering personalized data plans. Andre we already use this, like we have different data plans for different rates, right? So ಅದನ್ನೆಲ್ಲ ಏನ್ ಯಾವ್ದು ಕಂಟ್ರೋಲ್ ಮಾಡ್ತದ, ನೆಟ್ವರ್ಕ್ ಅಲ್ಲಿ PCRF ಅನ್ನೋ ಒಂದು ಇದು ಕಂಟ್ರೋಲ್ ಮಾಡ್ತದೆ. ಒಂದು ಯೂನಿಟ್ ಇಟ್ ವಿಲ್ ಕಂಟೈನ್ ಯಾವ ಯೂಸರ್, ವಿಚ್ ಯೂಸರ್ is using which data plane. For example, I use data plan of Airtel for which is 3 months data plan of 760 or 800 something. ಈ ತರ ಬೇರೊಬ್ರು ಇನ್ನೊಂದು ಪ್ಲಾನ್ ಯೂಸ್ ಮಾಡ್ತಿರ್ತಾರೆ, ಅವ್ರಿಗೆ ಬರೀ SMS ಇರ್ತದ, ಅಥವಾ he may use the internet. ಅವರು ಡೈಲಿ 1.5G ಯೂಸ್ ಮಾಡ್ಬೋದು ಅಥವಾ 2G ಯೂಸ್ 2GB ಯೂಸ್ ಮಾಡ್ಬೋದು ಡೇಟಾನ. ಈ ತರ ಪ್ರತಿಯೊಬ್ಬರು ಇನ್ಫಾರ್ಮೇಶನ್ ಈ ಸಾಫ್ಟ್ವೇರ್ ಅಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡ್ತಾರೆ in 4G. Yesterday we have discussed some concepts related to cellular wireless networks. Today we start with wireless local area network, which is more popularly known as WLAN. So it is basically a method of connecting two or more devices. You can see we have an access point here, where the access point is being connected to internet through Ethernet, right? So access point is a device which basically we call it as a router. Okay, so it routes the data, right? So it radiates the signal so that the nearby users using a particular passwords, it can easily access the internet. Okay, so this is somewhat like a router. So this is called as wireless local area network. So before to wireless local area network, we used to use wired local area network, right? So now we are using wireless local area network. Then WLAN specifications, that is wireless local area network. We have different standards of this network. Basically, the standards like IEEE 802.11 and upgradation of this 802.11 like 802.11a, b and g. Okay, so using different frequency bands. So 802.11 uses 2.4 gigahertz, 11a uses 5 to 6 gigahertz, whereas b and g uses the same frequency band. Bandwidth remains same, only the change is with respect to the data rate and modulation type used. So initially the basic 802.11 uses modulation type which is called as phase shift keying. We have already discussed about these modulation techniques in the earlier classes. So 802.11 uses OFDM, and then 802.11b complementary code keying. 802.11g uses direct spread spectrum, direct sequence spread spectrum, and OFDM. Whereas the data rates is the basic one has 2 Mbps, followed by 54 Mbps, 11 Mbps, and 54 Mbps. So what are the advantages of wireless LAN? So because it does not, it is not wired. Okay, so physical wires are not there. So it is easily any user who is nearby this particular device, this router, he can easily access this internet. So easily we can add or remove the workstation. Means workstation means the mobile user or a computer who wants to use this particular signal. So it provides high data rate due to small area coverage. Okay, it covers a limited range, whereas okay, it covers a limited range. Therefore, it provides a high data rate for the users. Okay, so move workstation while maintaining the connectivity. It means a person can, while using this particular connectivity, he can roam everywhere because it is a wireless. Within that range, he can roam anywhere and still be using the internet. Right. So these are some of the advantages of wireless LAN. Now coming to the next standard wireless network, which is called as Bluetooth. We all use Bluetooth. Okay, it is a short range wireless technology standard. Bluetooth is a short range wireless technology standard. So again, it is used for exchanging data between fixed and mobile devices. Okay, over short distance. We all know the Bluetooth ranges up to 10 meters. Within 10 meters, if two devices are there, they can easily connect and exchange the data with the help of this technology, Bluetooth standard. Okay, so normally that standard is called as Bluetooth as IEEE 802.15.1. This is the standard, and more popularly it is known as Bluetooth. Okay, And the data rate, it provides up to 1 Mbps or 3 Mbps depending upon the version, right? So we use Bluetooth technology in all the devices, like it may be a mobile station or it may be any other devices like laptop or computer, wherever, in even in audio systems, video systems, we use Bluetooth, so that you can easily access the data. So Bluetooth architecture, uh, we use two terminologies here. One is piconet and scatternet, right? So means a Bluetooth network, actually it is called as a piconet, but and if we connect two different Bluetooth networks, so here it is given a collection of interconnected piconets is called scatternet, right? So piconet means a single Bluetooth network connecting some 3 to 4 devices here. Similarly, the same two networks with 3 to 4 devices connecting each other, this is called as scatternet. Real-time application shown here. This is the master computer. To this particular device, all other devices are connected, like mobile phone, tablet, PC, laptop, scanner, printer, video projector, GPS receiver. Okay, these are all slave devices. It means all these devices access this Bluetooth. Similarly, here we have one more network and one more master computer, which gives the network or internet to these four devices. Okay, so connection of this network and this network is called as scatternet, but individual network, it is called as piconet. And the next concept is satellite communication. Okay, so satellite communication means we are using satellite to exchange the data. Okay, so communication is happening with the help of satellite. This is called as satellite communication. So normally, we have already discussed like what is ground wave propagation and what is sky wave propagation. In both of these cases, we can transmit and receive the data to a longer distance, but still it is limited to, for example, 1500 kilometer only with the help of sky wave propagation. Okay, so with the help of sky wave propagation, that is the signal taken from ground station to ionosphere layer, and then the signal getting reflected at the ionosphere layer and coming back to the destination. This can, here this application, we can use it for 1500 kilometer only. Okay, so if we still want to further transmit the data to a longer distance above 1500 kilometer, then we go for a satellite communication. Okay, so and the application of the satellite communication is everywhere. For example, it is used in mobile applications such as communication to ships, vehicles, planes, weather forecasting, handheld terminals, and for TV, satellite TV, right? Radio broadcasting we use. We use it for global mobile communication. We use it for military communication. We use it for global positioning system. All right. So we use this particular satellite communication. The application of the satellite communication is everywhere. So need for satellite communication helps to study environment, temperature, and space, means weather forecasting, and it sends pictures and maps of Earth because it is located far away from Earth. It can easily take the pictures of or maps of Earth, and we can access the data. So we can access satellite communication even we are placed in remote areas. And also with the help of satellite communication, we can do remote access, remote sensing. So remote sensing means, for example, if we there are some areas where a human cannot go and collect the data. For example, Amazon forest, it may be Amazon forest, or it may be in some areas like oceans, or somewhere where a human cannot go and collect the data. Okay, so there, with the help of satellites, we can easily take the pictures of that particular area, or we can collect other information of that area, and we can easily access the data, right? So these are some of the need why we go for satellite communication. So basic elements of satellite communication, uh, at one end we have user, another end we have satellite, in between terrestrial network system and earth station. So user, where the data is, if we want to send any data, this user sends the data to terrestrial system and to earth station, where we'll be having antenna and data processing units and control units. With the help of antenna, the signal will be taken to satellite, and this link we call it as uplink, means data transmission from ground station to uh, satellite station or space station, and from satellite to the receiving station, this is called as downlink. And again, at the downlink we have antenna, earth station, and we have different processing units, and then wherever the data is needed to be used, to that user the data is forwarded. So satellite, a repeater in space, receives the RF modulated carrier from all earth stations in the uplink and amplifies before sending in the downlink. Means we also have repeaters. So repeaters means, for example, if we have two users, and two users are located far away, then in between we'll be having repeaters. So what the repeaters will do, one user will be sending the data, the other user will be receiving the data. In between, repeaters will be there. The work of repeaters is to collect the data from one user, and it will amplify the signal, reduces noise, and it gives strength or power to the signal, and then it transmits further to the other user. Okay. And then what are the types of satellites? The types of satellites are, there are three types. One is low Earth orbit satellite. The second one, middle Earth orbit satellite or medium Earth orbit satellite, and geostationary Earth orbits. Okay. So what is the range? So low Earth orbit, the distance from the Earth surface to this orbit is 2000 kilometer. Okay. And 200 kilometer to 2000 kilometer. And the medium Earth orbit distance from the Earth surface is 10,000 kilometer to 20,000 kilometer. And GEO, geostationary Earth orbit, the distance is from 20,000 kilometer to 30,000 kilometer. So low Earth orbit satellites in this particular orbit circle Earth at a height of around 200 to 500 kilometer. Okay. And to have one rotation, okay, to have one rotation around the Earth. Here, these satellites being closer to the surface of the Earth have much shorter orbital periods, 95 to 120 minutes. Right? And the propagation delays is 4.5 millisecond. And at the Earth station, this lower Earth orbit satellite will be visible for around 10 minutes. And the application of low Earth orbit satellites, it is used for remote sensing. As I said, remote sensing means sensing the data, collecting the data of the remote areas like Amazon forest or some area where human cannot reach. Okay, so collecting the data of those areas is called as remote sensing. Okay, so these satellites which are placed at low Earth orbits, the application of these satellites are remote sensing and mobile communication services. So what are the disadvantages of these low Earth orbit satellites? These are, many satellites are required for global coverage. Okay, so all over the world, if you want to have the data exchange or data or the area coverage, then we need to deploy many more satellites. Okay. And the complexity here, because there are many satellites, the complexity will be more. And these satellites are having a very short lifetime, that is about 5 to 8 years. Coming to medium Earth orbit satellites, as we have seen, the distance is approximately from the Earth's surface. It is from 10,000 to 20,000 kilometer. Okay, and these are having the orbital period of 6 to 12 hours, right? And the propagation delays, the signal propagation delay is 70 to 80 milliseconds. And what are the disadvantages? So due to larger distance to Earth, delay increases to about 70 to 80 milliseconds. You can see the delay in case of LEO satellites is 4.5 milliseconds, but when you consider this, when you compare it with MEO delays, it is 70 to 80 milliseconds, because these are placed very far away from Earth's surface. And what about geostationary Earth orbits? The orbital period should be equal to 23 hours 56 minutes. Okay, so orbital period is about 23 hours 56 minutes, means it takes these many hours to take one rotation of the Earth. And this geo orbit is a prograde orbit whose orbital period is equal to Earth's rotational period. Means Earth moves from west to east synchronous with Earth, called geostationary atlas. Means as the Earth moves in the same, this satellite is also having the same rotational period. This is the meaning. And the height of this satellite is 36,000 kilometers. So applications, we can find the application of these satellites in TV application, multi-point communication, mobile services, weather forecasting. And this is about satellite communication. Coming to the next topic, optical fiber communication. We have discussed many times optical fiber communication. When we considered the example of wired communication, the more popular wired communication is the optical fiber communication, right? So the channel here is optical fiber. When we have a transmitter and receiver here, in between transmitter and receiver, the data will be sent through this optical fiber. So optical fiber, if you want to send the data in this optical fiber, the data should be converted into a light ray. Therefore, light ray is taken inside this optical fiber, which can reach to this receiver. So here in this figure, you can see they have given LED, electrical input signal, LED transmitter, optical fiber, light ray trapped in the core of the fiber, receiver, photodiode, electrical output signal. Okay. So LED is nothing but a input transducer. Okay. So what it does, it basically converts an electrical input signal to a light signal. Okay. So LED means light emitting diode, which converts an electrical signal into a light signal. At the transmitter point, we use LED or laser. We have discussed both these two devices, LED and laser. We also discussed about what operation takes place inside an LED and laser. Okay, so inside an LED, spontaneous emission takes place. You people can remember, and inside a laser, a stimulated emission takes place. Okay, so these two devices are considered to be placed at transmitting level in optical fiber communication, which converts electrical signal into a light signal. And this light signal is taken into an optical fiber through total internal reflection, right? This process is called as total internal reflection. And the light signal at the receiver, it is converted into electrical signal with the help of photodiode, which is the output transducer. Okay, so what it does, it will take light signal as an input and generates electrical signal. corresponding electrical signal as output. So how the optical fibers will be there? Basically, optical fiber is made up of silica or sand, right? And above that optical fiber, we have many more coatings, which will provide strength and which will protect the optical inner optical fiber from any uh, a pressure, or because these optical fibers will be laid in the ground due to some pressures. It may be due to heavy vehicle which are going on the road. Okay, so because these optical fibers are beneath the road, under the under the ground, it has to withstand pressure and load on this. So therefore, we'll be having many more coating layers above this optical fiber, like flexible buffer tube, water blocking binders, ripcord, aramid strength yams, jacket, polyethylene jacket. Okay, so which will protect the inner core from the external damage. And what are the advantages of optical fiber? It is low cost because, as I said, this is made up of silica or sand, and which is abundantly available. So sand is abundantly available, which is a raw material to make this optical fiber. Therefore, it is of low cost, and it is very lightweight and compact. It means the size of this particular optical fiber is equal to a human hair. A human hair, the size of that optical fiber is so much less in terms of microns. Okay, so its weight is also less and it's very compact. It can carry higher capacity, means the bandwidth is very high. You can accommodate more signals into an optical fiber. uh, Less signal degradation, means when you compare this signal degradation parameter with other wired communication channels like coaxial cable or conductor cable, optical fiber cable, here signal degradation is very less. Okay, so the quality of the signal which is received at the receiving end is very good compared to the conductor cable communication and coaxial cable communication. And no electromagnetic interference, it will not affect. Okay? Electromagnetic interference will not affect the optical fiber because it will be having coating, and as well as the core will be carrying optical rays, not the electrical signal. Therefore, no interference will takes place. Okay, so security is high, it is high efficient and long lifespan. It means once the optical fiber is manufactured and deployed for the use, then these will come for around 100 years. You can use this optical fiber for around or over 100 years. So therefore, it is this is an advantage of an optical fiber. The generalized or general communication system with the help of optical fiber communication system, optical fiber is given here, the block diagram, wherein we can see this is the transmitter side and this is the receiver side, and in between we are having a channel, optical fiber as a channel. So at the transmitter side, we have information source which generates information. It may be any information, like it may be a voice information, video, data, it may be analog information, image, any kind of information. This information is taken to a transmitter where we will convert it into electrical signal first. Okay, and then this electrical signal is again converted into optical signal with the help of optical emitters. Okay, so OE means optical emitters, means light emitters these are. Okay. So the electrical signal is converted into light signal here, and here is input channel coupler, means this light signal should be taken into the optical fiber. Okay, so to do that, we have optical couplers here, which will couple the signal from the optical emitter into the optical fiber cable. And now, as because these optical fibers will carry the data from one end to another end, and the distance between these two, transmitter and receiver, will be more if it is a long distance communication. Then in between we should have some repeaters. As discussed earlier, repeaters will amplify the signal before they are taken to uh, the destination. In between the transmitter and receiver, at some distances, will be having uh, many repeaters which will amplify the signal, which will give strength to the signal, so that that signal will be taken to longer distance. And this is optical fiber cable. Once at the receiver, the signal before receiving will be having output channel coupler, which will couple the signal from optical fiber into the detector. Hmm? Optical detector it is, right? So optical detector will convert the light signal into electrical signal, and here in the receiver we'll be having some processing units which will convert this this electrical signal back to our application, wherever it is. If you want to give the signal to the speaker, or if you want to give the signal to TV or any kind of device, computer. Okay, so there the signal is given. This is the general diagram of block diagram of optical fiber communication system. The last topic is microwave communication. So the electromagnetic waves, right? So with wavelengths from 1 meter to 1 millimeter, right? So microwave communication means, as the name itself suggests, here the wave is micro, means it is from 1 meter to 1 millimeter, 300 megahertz to 300 gigahertz of electromagnetic spectrum are categorized as microwaves. I'll show you the electromagnetic spectrum. Okay? This is the electromagnetic spectrum, wherein we'll be having different wavelength in this spectrum, different frequency, and this is where the microwave signal is there, right? So 10 raised to minus 2. So this particular band of this electromagnetic spectrum is used for has a microwave communication. So basically, this is a line of sight communication. Means the transmitter and receiver will be in line of sight. Okay, and which uses high frequency beams. It uses high frequency beams of EM waves to provide high speed wireless connections that can send and receive voice, video, and data information. Again, these are used for data transmission and reception. So more oftenly, these microwave signals are divided into three categories. One is ultra high frequency, which is ranging from 0.3 to 3 gigahertz, and super high frequency from 3 to 30 gigahertz, extremely high frequency from 30 to 300 gigahertz. You can see the frequency, wavelength, and application here. So the frequency here is 50 to 60 hertz. The wavelength used is 6,000 to 5,000 kilometer, and application is AC electricity transmission. Okay. Likewise, 3 to 30 kilohertz, the wavelength used is 100 to 10 kilometer, and the application is submarine communication. Likewise, we have different frequencies which are used for, which uses different, which has different wavelengths. Different frequency obviously will be having different wavelengths, and these different frequency bands are used for different applications, right? And they have given name for these bands, like frequency range. If it is from 1 to 2, they have given the band name as L, which is used for GPS, satellite, mobile phones, right? From 2 to 4 gigahertz, the band name is S, which is used for weather radar, surface ship radar, and some communication satellites. 4 to 8 gigahertz, C band, so it is primarily used for satellite communication and satellite TV. X band, the frequency range is 8 to 12 gigahertz, so used for civil, military, and government engineering for weather monitoring, air traffic control, etc. Likewise, we also have some more bands like Ku, Ka, and V used for satellite services. Properties of microwaves. So this will radiate electromagnetic energy with shorter wavelength, and these waves are not reflected by ionosphere. We have seen the ionosphere layer, the fourth layer above the Earth's surface. So these waves are not reflected by that ionosphere. And as I said, this is a line of sight communication. Okay, this is a line of sight communication, and microwave currents can flow through a thin layer of a cable. Uh, One more topic called as frequency modulated microwave communication system, wherein they have shown FM microwave transmitter and FM microwave receiver. Now, what is a FM microwave transmitter? This is the block diagram of FM microwave transmitter. So, as the name is transmitter, it will transmit the signal. So here we have a baseband input signal. Normally, baseband input signal means it is the original signal. Okay. So original signal is taken into pre-emphasis network where initial amplification of the signal will takes place. Okay, and then it will also provide uniform signal to noise ratio. Okay, and then this signal is taken to FM deviator where they have shown IF means intermediate frequency. It is means the signal here will be converted into intermediate frequency. Okay, before take and once it is converted to intermediate frequency, again it is amplified here, right? So all the signal which are coming here are converted into intermediate frequency, and it is amplified by intermediate frequency amplifier. Then it is taken to a mixer. Okay, so it converts that in intermediate frequency signal into RF microwave frequency. Okay, and once this IF signal, intermediate frequency signal, is taken to mixer, here is where modulation takes place, right? So modulation with the help of microwave generator. Microwave generator means it generates a microwave signal. Okay. Therefore, this IF signal is converted into a microwave radio signal, and then before transmitting it, we will band pass a filter. We will use a band pass filter, thereby band limiting a signal, and then we will send that signal to the atmosphere. And after that, at the receiver section, we just have the reverse steps. Means we will receive uh, from the antenna, and then the steps will be just a reverse of the transmitting section. You can see here. Initially, the signal is received here by the receiving antenna, and then a band pass. This is the channel separation network. Means one channel is separated by another channel, and then we have a band pass filter which will band limit the signal. Means only uh, a particular band of frequency is selected and it is taken further to mixer. Here is where demodulation takes place. Okay, from microwave signal to intermediate frequency signal conversion is done here, and then the signal is amplified, and then our original signal is detected here. Okay, with the help of IM detector, right? So after that, it is taken as a original signal. From this, de-emphasize means again the signal is amplified here. Once the signal is converted into our original signal, before it is given to the application, it is again amplified and then given to the application. Again, the same concept. Repeaters means these are used in between. For example, if this is one station and this is one more station, this is one station, transmitting station, and this is a receiving station. then in between will be, if these two are placed very far away from each other, hmm, there is a long distance in between these two, then we'll be using these repeaters. Okay, so the work of repeater is to just collect the signal from the transmitting end, amplify it, and then send further. And again here it will collect the signal, then amplify it, it will send further. Collect the signal, amplify or denoise, and then uh, give strength to the signal, and then forward it, so that here the signal is received. Okay. This is the work of a repeater.